Great, 8th graders. All right, today's lesson, we are going to divide monomials. So last week we talked about monomials and polynomials, binomials, all right, and we multiplied monomials last week. So monomial means one term, and that term can have a variable that may or may not have an exponent. Well, there's always an exponent. It could be invisible. But either way, so last week when we multiplied monomials, we were seeing things like 6x to the 4th times 2x to the 3rd, and I gave you the easy steps of just multiplying the two numbers, 6 and 2, to get 12, and then we would multiply the two powers, x to the 4th times x to the 3rd, using our power rules, where you keep the base the same, and we add the exponents. So 4 plus 3 is 7. All right, so you get 12x to the 7th. All right, today's lesson, we are going to divide monomials. All right, so we're still going to use our rules that we use with exponents, except for division. All right, now a couple things I need to talk about before we even start. All right, x to the 0. If you see x to the 0 anywhere, any number to the 0 power, it doesn't have to be a variable, it could be 2 to the 0 power, it could be 1,000 to the 0 power, that is 1. All right, anything to the 0 power is 1. Another thing we need to get out of the way early is negative exponents. Negative exponents mean division. All right, I'm just going to say negative exponents equal division. All right, and you'll see what I mean. And this is review. We have done this before, all right, but we didn't get a ton of practice with it. All right, so let's do some examples with dividing monomials. So let's start with an easy one. So example number 1. Let's say we have 7x squared divided by 7x squared. All right, guys, this is one of the very first things you guys probably learned about in 3rd grade when you started doing division, maybe even 2nd grade now. All right, anything divided by itself is 1. So I have 7x squared on top divided by 7x squared. All right, anything divided by itself is 1. All right, now if you want to cancel out, you could think 7 divided by 7. That gives you 1. All right, whenever I cancel, I always write a little 1 there. X squared divided by x squared, that cancels out. Write a little 1. All right, and then I get a numerator of 1 times 1, which is just 1, and a denominator of 1 times 1, which is 1, so it's just 1 over 1, which is 1. All right, so that was an easy example. You'll see some of those on IXL. Second example. All right, let's do 12x to the 4th divided by 3x squared. All right, I am going to show you 2 ways to approach these questions. All right, first way is the long way, but it always works. All right, it's what you do when you forget what to do. All right, and it's my golden rule for exponents. You expand. All right, so if you're stuck, you expand. All right, so I'm going to rewrite this as 12 times x to the 4th, but I'm going to expand x to the 4th. X times x times x times x. That's what x to the 4th actually means. All over 3 times x to the 2nd, which is just x times x. Now, since I expanded, I can cancel things out. All right, 12 divided by 3, that's just 4. All right, now I can cancel out x's. All right, I cancel this x out with this x. All right, gives me a 1 and a 1. I cancel the second x out with the last x on the bottom. Gives me a 1 and a 1. Now, what I'm left with on top is essentially 4 times x, which we can write that with an exponent of 2. So I'll call my numerator 4x squared. And my denominator, I really don't have anything. I just have 1 times 1 times 1, which is just 1. All right, so my final answer for this question is just 4x squared. I don't even need it over 1. 4x squared. All right, so that's the expanded way to do it. Now, you guys like to be fast, all right? I'm pretty sure all of you like to be fast. I've taught all of you. All right, you like fast stuff. All right, so the easy way to do this is you divide the numbers. All right, so step 1, divide the numbers. 12 divided by 3, that's easy. 4. And then you have to divide the powers. Now, when you divide powers with the same base, which in this case, x to the fourth divided by x to the second, you keep the base the same, and you subtract exponents. 4 minus 2 is 2. So I get a final answer of 4x squared. And that was much faster than expanding. All right, so you can always divide the numbers, divide the powers, and subtract the exponents. All right, example 3. Let's do 4x to the 0 power all over 2x squared. All right, two ways to think about this one. All right, say you didn't know what x to the 0 was. All right, let's just imagine for a second you don't know what it is. All right, well, what did Mr. Legish say? Divide your numbers, so 4 divided by 2 is 2. Keep your bases the same, x, and subtract your exponents. 0 minus 2 is negative 2. All right, that's all swell right now, except math teachers do not like negative exponents. All right, negative exponents mean division. So all I'm going to do to make this a little better, all right, so my eye stops twitching, is I am going to write this x to the negative 2 in the denominator. So this is going to become 2 divided by x to the second power. All right, and that is the same exact thing. All right, it's just in a more acceptable format. All right, now, also with this question, you could have seen x to the 0 and been like, hey, that just means 1. All right, that means 1. All right, so you could have rewritten this as 4 all over 2 to the x squared. 4 over 2x squared. Who can't talk? All right, and then we could do a little simplifying. All right, 2 goes into 4 twice, and we're left with 2 over x squared. All right, same answer, just two different ways to think about it. All right, if I were doing this, I would probably see x to the 0 and automatically know it's 1. All right, two more examples. Example 4. All right, let's have 6x divided by 2x to the 5th. All right, so I'm going to divide my numbers. All right, 6 divided by 2 is 3. Keep my base the same, x. Now I need to divide or subtract my exponents. Now, if you don't see an exponent, that means there's a 1 there. So I have to do 1 minus 5, which is negative 4. All right, ooh, negative exponent. Now again, I don't like that. So I am going to take that power, if it has a negative exponent, and I'm going to put it on the bottom of a fraction. All right, so this becomes 3 divided by x to the 4th, because negative exponents mean division. Okay, one more. Let's get a little more challenging. I'm running out of space here. I'm going to put example 5 over on the right side here. Let's say we have 6 times v times w to the, well, what do I want? I want 6v to the 9th times w all over 3 times v times w. All right, so we have two variables here. We've got v and w. All right, same rules apply, guys. Divide the numbers, all right, and then divide the powers. Now make sure you're dividing the powers that have the same base, all right? So 6 divided by 3, that's just 2. Now I'm going to do v to the 9th divided by v. They go together because they have the same base. So I keep the base the same, v. I'm going to subtract my exponents. 9 minus 1 gives me a power of 8. Now I need to divide w by w. Well, guess what? That's just 1. And that's actually why anything to the 0 power is 1, because if I were to keep my bases the same, I would have w, and then I would subtract the exponents. 1 minus 1 is just 0. All right? That's why anything to the 0 power is 1. That's like a very short proof of it, but I won't confuse you anymore. All right, guys. So dividing powers with the same base, pretty much the same as dividing monomials. All right, you divide the numbers, you divide the powers, you keep the base the same, you subtract the exponents. If you ever get stuck, expand. All right, or send me an email and I'm glad to help.